right, so let us briefly recap what we did on yesterday. So before we start into Trig, there are certain basic skills that you need. So we're not gonna go through all of this again. Those of you who weren't here, all of my lessons are recorded. You got to go back yourself and watch it yourself. And you come in after school during asynchronous time if you want additional instruction with it. But we reviewed how to round numbers, ratios and proportions, setting up ratios, solving proportions, working with angles in a triangle, and simplifying square roots. So simplifying the basic square root. So parts A, B, C, and D, we already took care of. So now we're going to be working with the last two parts, which are rationalizing the denominator. Sounds weird, but I'll explain what it is. And Pythagorean Theorem. So since we deal a lot with right triangle trig, we're going to be dealing a lot with Pythagorean Theorem. So let us go ahead and look at part E, which is rationalizing the denominator. So when it comes to rationalizing the denominator, the primary rule of thumb is this. You cannot have a square root at the bottom of a fraction. You cannot have a square root at the bottom of a fraction. So if you have a square root at the bottom of a fraction, we have to get rid of it. So this is how we get rid of a square root sitting at the bottom of a fraction. First step, multiply the top and the bottom of the fraction by that square root. So for part A, example A, you have 5 divided by the square root of 2. So that square root of 2 can't stay there. So you're going to multiply the top of the fraction and the bottom of the fraction by the square root of 2. First, you multiply the top and the bottom by the square root of 2. Now we continue. So 5 times the square root of 2 is 5 square root of 2. You can't do anything with that. You cannot do anything with that. Square root of 2 times the square root of 2 is the square root of 4. Square root of 4 is easy. Square root of 4 is 2. So we simplify the top and the bottom. So step 3 is to break down the square root if we need to. Most of the time you won't have to do step 3. The square root of 2, remember, is one of those square roots that don't break down. Square root of 2 is one of those numbers. So 2 is not going to break down anymore. So that ends up being your final answer. That ends up being your final answer. Any questions with part A? Right. Not seeing any or hearing any, so I'm assuming that everyone is good to go. Go to part B. So part B, we do the exact same thing. 10 divided by the square root of 5. Same rules apply. The square root of 5 can't stay there. So you need to multiply the top and the bottom by the square root of 5. And 10 times the square root of 5 is 10 square root of 5. Square root of 5 times square root of 5 is the square root of 25. Square root of 25 is 5. Any questions before we continue? Before we finish off the problem? All right. So there's one part that needs to be finished off. So the square root of 5 can't be broken down. That's one of your numbers that won't break down. But this 10 and that 5 can divide. 10 divided by 5, the last time I checked, is 2. 2 square root of 5. That gives you 2 square root of 5. Now your problem's finished. Questions on part B? All right, let's do 2 more. Again, if you have questions, you have to ask. I can't read your mind. You can type it in the chat, come off mute. Gotta take the initiative. So 4 square root of 6, same rule applies. Multiply the top and the bottom by the square root of 6. 4 times the square root of 6 is 4 square root of 6. Square root of 6 times square root of 6. If both numbers are underneath the square root, then you can multiply them together. But square root of 36 is 6. So square root of 6 doesn't break down. It's one of those numbers that doesn't break down. But 4 and 6, both numbers you can divide. You can divide both of those by 2. So 2 square root of 6 over 3. 2 square root of 6 over 3. And so far, most of what we're working with are basic numbers. Any questions? So we scroll to part D. All right, so for part D, 9 over the square root of 3. Multiply the top and the bottom by the square root of 3. So 9 times the square root of 3 is 9 square root of 3. Square root of 3 times square root of 3, square root of 9. Square root of 9 is 3. 9 divided by 3 is 40. Divided by 3 is 3. So the idea of rationalizing the denominator is to get rid of a square root that's sitting at the bottom of a fraction. So you only have to do this if there is a square root in the denominator of the fraction, the bottom of the fraction. Any questions, part E, before we do Pythagorean theorem? All right. So let's look at Pythagorean theorem, and then we'll start Trig. So Pythagorean theorem should be nothing new. Everyone was in geometry once before. So that's where we deal with Pythagorean theorem. So Pythagorean theorem is that formula of a squared plus b squared equals c squared. So A and B are attached to the right angle. Wherever the right angle is, A and B are attached to it. C is the side directly across from the right angle. C is always across from the right angle. So when you're labeling for Pythagorean theorem, wherever the right angle is, A and B are attached to the right angle, and C is the side that's left over. Find the right angle. A and B are attached to it. C is the side that's left over. Find the right angle. A and B are attached to it. C is the side that's left over. C is the hypotenuse. So some of you may just know that off the top of your head. Some of you may need to label it so that you can see it. There's no shame in the game. But now we're going to solve it. So if you can label it, you can plug it into a formula. A squared plus b squared equals c squared. That's the Pythagorean theorem. That's the Pythagorean theorem. So let's do some work. So Pythagorean theorem here, you have a squared plus b squared equals c squared. So a is 9, b is 12. Nine to the second power is 81. 12 to the second power is 144. And 144 is 225. So to get your final answer, you need to take the square root. So the square root of 225 is 15. Whether you use your calculator to get it or not. 15. We're nice and neat number. We're done and we're good to go. Again, it's not a hard problem. but you need to show your work and put in the work. Again, if you don't show your work, I'm just going to assume that you copied and give you a 0. Any questions before we continue? All right, problem 2. For example B. So we already labeled it. So a squared plus b squared equals c squared. That's x squared plus b6 squared equals 9 squared. So plug in what they gave you. If you can at least do that, it'll at least get you the sympathy point. So 6 squared is 36. 9 squared is 81. So, when both numbers are on the same side, you can add them. But when both numbers are on different sides, you have to subtract. So x squared equals 45. Anyone with any questions before we continue? All right, so now we need to take the square root. But here's the problem. 45 is not a perfect square. We are not giving decimal answers. No decimal answers allowed. So, 45 is not a perfect square? Okay. We break down the square root. So we need two numbers that multiply 45. One of them being a perfect square. So we go back to our nice little chart from yesterday. So there's the first set of perfect squares. So 45 divided by 4 is a decimal. That doesn't work. 45 divided by 9 is 5. So 9 times 5. Square root of 9 is 3. Square root of 5 is square root of 5. So that's your answer. Okay. Doing the problem the right way takes practice. Do not give the decimal answer because I don't know how to do it. I don't know how to break down the square root. You don't know how to break down the square root, then you ask. You don't get to do it whatever way you feel like just because you don't know how to do it. People will help you if you choose to help yourself. But I'm telling you now, if you give the decimal answer for that, it's getting marked wrong. So we're going to do one more example, then we can move on and start grading. Alright, an example C. So again, we get the labeling already. So now we use Pythagorean Theorem. So x squared plus 8 squared equals 16 squared. So x squared plus 64. 16 to the second power, 256. So example C is just like example B. If both of your numbers are on different sides of equal sign, you subtract. If they're on the same side, you add. So x squared equals 256 minus 64 is 192. Still have to take the square root. 192 is not on your list. So we have to break down the square root of 192. So I'm going to tell you what the best option is, primarily just for the sake of time. That's 64 times 3. Now, you could have used 192 divided by 4. So 192, if you use 4 will work. That will give you 48, but that means you got to break down 48. And then you would have to break down 12. You would have to keep breaking it down. The reason why I chose 64 and 3 is because you only have to do it once. You only have to do it once. So when you take the square root, if you get a nice number back, you're good. If you get a decimal, then you need to break down the square root. If you give a decimal answer, your problem is going to get marked wrong. Any questions with Pythagorean Theorem before we transition into Trig? And all the things that we did yesterday and today are basic skills that you need so that you can do well in Trig.